Hi, this is Mrs. Kidman, and in this video, we are going to be discussing how we can add and subtract rational expressions. Now, this is part 2 to a previous video. In the previous video, we discussed how we can find common denominators and how we can use those common denominators to change the problem so that we can add or subtract them. In this video, we are going to be focusing more on how we can use factoring the denominator to figure out what a least common multiple is so that we don't have to do quite as many multiplying and quite as many calculations. So let's take a look at what we can do here. Now in this first slide, we are just going to review what we talked about in that previous one. So if they do have the same denominator, what we're going to do is we're just going to add those numbers straight across or subtract them. So in this case, we get a 2x minus 5 over x plus 6. Now, when we get this, what we want to do is we can put both of those binomials in parentheses because they aren't going to be combined with anything else. They're as simple as they get. There's no like terms to combine them with. And so then we end up with a 2x minus 5 on top and an x plus 6 on the bottom. Now I like to put them in parentheses to remind myself that I can only cancel them out if they have something else that looks the same. So in this case, because they don't have something that looks the same, that's as simple as we're going to get. In this other problem here, we need to find a common denominator. And remember, one way we talked about is just by multiplying by the other. So we have an x plus 1 on top and bottom on this side. We can multiply by x plus 6 on top and bottom on this side. And we end up getting a 2x times x plus 6 plus 5 times x plus 1 all over x plus 1 times x plus 6. Then we can use that distributive property and we end up getting 2x squared plus 12x plus 5x plus 5 is over x plus 1 over x plus 6. And then we can combine those to get a 2x squared plus 17x plus 5 all over x plus 1 times x plus 6. Now, looking at this problem here, we can try to simplify this more by factoring out the top. So I'm going to do 2 times 5 because we have that coefficient in front to get 10. And I want two numbers that multiply to 10 and add to 17. Well, guess what? There aren't any whole numbers that'll do that. And because we typically factor in whole numbers, unless we want to use the quadratic formula, we are just going to stop here. So because there are no whole numbers, we know that this isn't going to factor pretty. And so this is that point where we're going to stop at. That is our simplest form. So it works great to multiply by the opposite denominator when there's something small. However, sometimes we start running into problems like this one, where what we're multiplying by really isn't that small. And so what we need to do is we actually are going to practice a new skill where we factor out the denominator so that we can figure out what is the least common thing, or what's the one thing that's not in common between these two sides and multiply just by that. So I don't have to multiply by everything. So let's take a look at this first one here. So if I'm looking at this first rational expression, if I factor out the bottom, I get 3 times 3 times x times x. I'm going to add that to the factoring of the bottom of our second one, which we can actually factor out a 3x from this, and we get an x plus 1. So 3 times x plus 1. So then we're asking ourselves, what here is in common? Well, that's going to be our 3 and our x. What are things that I still need? Well, on the right, we still need a 3 and an x. On the left, we need an x plus 1. And then what we're going to do is we are going to take that and then multiply both sides by the things that they need. So this right equation still needs a 3 and an x, so that's what we're going to multiply by. The left equation only needs an x plus 1. So we're just going to multiply by that. And so then what we end up getting is 7 times x plus 1 plus x times 3x all over that 3 times 3 times x times x times x plus 1. Okay, so we end up getting that common denominator because notice how here we have 2 3's, 2 x's, and an x plus 1, 2 3's, 2 x's, and an x plus 1. So that's our common denominator. And then we can combine what's on top here. So on top, we end up getting 7x plus 7 is equal to, or 7x plus 7 plus 3x squared, all over that 3 times 3 times x times x times x plus 1. Now I know you're thinking writing the denominator like this is tedious, and you're right, it can be. However, if we multiply it back out, later when we're trying to simplify our expression, we are going to have to factor it again, and so sometimes it's easier just to leave it factored. Now I am going to rewrite the top of this expression here in standard form, so we get a 3x squared plus a 7x plus a 7 all over that 3 times 3 times x times x times x plus 1. And what we want to do is we want to see, is it possible for us to factor the top of this expression here? So I'm going to multiply that 3 times 7, and I want to find two numbers that multiply to 21 and add to 7. Well, if I'm thinking of numbers that multiply to 21, the numbers that I can think of are 1 and 21, 3 and 7, or -1 and -21 and -3 and -7. Now, are any of those going to add up to 7? They're not. So this is actually as simplified as this expression gets. And so because this is as simplified as it gets, we're going to end up just writing it as 3x squared plus 7x plus 7 all over, we're going to now combine our denominator, 9x squared times x plus 1. And we can leave it like that. If you want to continue combining your denominator, you can, but that's kind of what we're going to do there. So what we're doing is we're going to factor out the bottom as much as we can so we figure out what we need to multiply it by. So let's take a look at another example where we're going to do the same sort of thing. So in this case, we've got 12 divided by x squared plus 5x minus 24 plus 3 divided by x minus 3. And what we want to figure out is, what do I need to multiply by to get a common denominator? Now, of course, I could always multiply by x squared plus 5x minus 24 on top and bottom, but that seems like a lot of work to have to do that foiling where I have to multiply my x times this and this times this. That just seems like way more work than what's worth it. So what I'm going to do is I'm actually going to factor my denominator here and see if we can get an x minus 3 out so we know what we have to do. So we end up wanting two numbers that multiply to -24 and add to 5. Well, that's going to be -8 and +3, or +8 and -3, my bad. And so then we end up getting 12 over x plus 8 times x minus 3 plus 3 over x minus 3. Now notice how simple it is for me to just multiply this side times x plus 8 on the top and bottom. So what it does is, it's not that we can't multiply by that x squared plus 5x minus 24, but we would rather multiply by less. So there's less work for us to do there. So we're going to multiply by that, and we end up getting 12 over x plus 8 times x minus 3 plus that 3 times x plus 8. And so what that's going to end up doing is we are going to end up getting a 12 plus 3x plus 24 all over x plus 8, x minus 3. And then we can combine like terms here, and we get 3x plus 36 over x plus 8, x minus 3. And then if we factor that top there, we get 3x plus 12 over x plus 8 and x minus 3. Okay, so this is that simplest form that it can go to. Notice how there is nothing else that we can cancel there. So that is as simple as it gets, but we can combine those terms together. It's a ton easier to do that factoring at the beginning, so we don't have to factor as much later. If we didn't do the factor at the beginning, then we would have to factor out as well and then cancel what's in common, and that just is an extra step that nobody wants to do. So let's take a look at one last example here in which we follow this process of finding a common factor between the top and the bottom, or a common factor between the two bottoms that might already exist that we only can find by factoring out the bottom. So let's take a look at this example here to see kind of what happens. So what I'm going to do is, just like before, factor out the bottoms. So I've still got an x plus 2 on top here, but now I've got a 2 times an x minus 1 plus this negative 2x minus 1 on top over, I'm going to factor the bottom here. And I want two numbers that multiply to 3 and add to -4. And those are going to be -3 and -1. So we get an x minus 1 and an x minus 3. So what do we need to make these in common? Well, the left side just needs a 2. Or the right side just needs a 2. The left side needs an x plus 3. Or an x minus 3. Ooh. Excuse my words. An x minus 3 over an x minus 3. So what we can do is we can multiply by those. And on top here, I'm going to get an x plus 2 times an x minus 3 over a 2 x minus 1 x minus 3 plus 2 times -2x minus 1 over x minus 1, 2x minus 1 times x minus 3. Now, I know before we just had to use the distributive property. In this case, we are actually going to have to FOIL out these problems in addition to using the distributive property on this right side here. So we are going to get a long expression on top. And then what we can do is we can combine like terms and see if we end up getting something that can cancel. So as we multiply this out, our top gives us an x squared minus 3x plus 2x minus 6. This side gives us a minus 4x minus 2. And that whole thing is going to be over that 2x minus 1, x minus 3. Okay, and then what we're going to do is just like before, combine all of the like terms that we can in this expression. So we've got 1x squared. If I do negative 3x plus 2x, I get negative 1x. Minus 4x is a negative 5x. And then we end up getting a negative 8 over here. And so with that, we can end up getting an expression of 2 times x minus 1 times x minus 3. And we can try to factor out that top there. And we factor it out to get two numbers that multiply to negative 8 and add to negative 5. And as we're thinking of numbers that multiply to negative 8, we get negative 1 and 8, negative 2 and 4. And these ones add up to 7, and these ones add up to 2. We can also do a negative 8 and a 1, which will add up to a negative 7, and a negative 4 and a 2, which will add up to negative 2. And so because none of those work, this is as simple as our expression gets there. However, if we were to get something on top that cancels out, we can always cancel things out. So if you have any questions, feel free to reach out, but that is how we can add and subtract rationals in order to find a common denominator by factoring the denominator first and then multiplying by what's in common. Please reach out if you have any questions, but that is part 2 to adding and subtracting rational expressions.